today we're extending to our 1.7 lesson to include the distributive property. The first thing we want to do is change any subtraction into adding the opposite. So we want to change any subtraction into adding the opposite. Secondly, distribution is out when you share, it's all about multiplying. So we want to multiply each term by the outside number. So you want to multiply each term by the outside number. And I'm just going to use the hashtag. All right, here we go. 3 times x minus 2. The quantity, the difference, x minus 2. This is saying 3 times x plus 3 times 2. 3x plus 6. You do not need that second step that I wrote. I'm just showing you what I'm doing. I'm multiplying each term by the outside number. That was my strategy. 4 times the difference of 3 and 2, I can rewrite this as plus the opposite. This is 4 times 3 plus 4 times negative 2 is a negative 8. Let me just show the multiplication. This is 4 times negative 2, 12 plus negative 8, which is 4. X plus 4 times 3, timesing the x and the 4 by the outside number. I get 3 times x plus 3 times 4. 3x plus 12 is the final answer. I cannot combine them. They are not like terms. It is not 15x. It's just 3x plus 12. Next one, I see minus. I can plus the opposite. So 7 times x plus 7 times negative 5. 7x plus a negative 35. We don't leave it like that. Okay, you don't leave it like that. Because there's 2 signs in the middle, it's not really fully simplified. You rewrite it as 7x minus 35. If you plus a negative, you're really minusing. Okay? 7 times 2x plus 1. Distributing it through. We get 7 times 2 is 14x. Plus 7 times 1 is 7. Answer is done, fully simplified because I don't need to combine like terms. Lastly, 9 times the difference of 4 and x. I see the minus, I'm going to add the opposite. 9 times 4 is 36, plus 9 times a negative x would be a negative 9x. You want the x term first. Proper math says put the x term first. So I rewrite this as negative 9x plus 36. I can do that because that utilizes the commutative property of addition. Order doesn't matter. Okay, I can flip them around if I want, only for addition and multiplication. Okay. Next concept with today's lesson is distributive property in mental math. The first thing you want to do is break numbers up into their place values. So you want to break the numbers up into their place values. The tens, the ones, the hundreds. And then all you're going to do is add them all up. I'll just write add. For instance, if I said to do 7 times 23 and your head quick, you're like, no, I need some paper or whiteboard. But you can rewrite this as 7 times 20 plus 3. That's expanding. That's making it into its place values. The 2 represents 10, so 20. The 3 represents 1s. Now I can distribute. This would be 7 times 20 is 140, plus 7 times 3 is 21. I can quickly add that together to get 161. Okay, the next one, I'm going over negative 5 times 134. I can use distributive property to turn this into, I'm going to do it on top here, negative 5 times 100 plus 30 plus 4. Breaking it up. This 1 represents 100, the 3 represents the 10s, and the 4 represents the 1s. Now I can go negative 5 times 100 is negative 500. Plus negative 5 times 30 would be negative, what? Negative 150. Plus negative 5 times 4 is a negative 20. They are all negative, so I can add them. 5, 650, 650 plus 20 would be 670, and just make it negative. Okay, expanding this next one out, 6 times 47. 47 means I have a 40 and I have 7 1s. So I can expand this out into 6 times 40 plus 7. Expanding it into its place values. The 4 represents 40, the 7 represents 7 1s. Multiplying, this turns into 6 times 40 is 240, plus 6 times 7 is 42, which is 282. Next one, expanding it out, this turns into negative 2 times, I have an 80, and I have an 8. Negative 2 times 80 is a negative 160, plus negative 2 times 8 is negative 16. They're both negative, so I just add them up. That would be negative 176, and make it negative. 4 times 37, breaking it up. This is 4 times 30. I have a 30 and I have a 7, plus 7. 120 plus 28, distributing the 4. 120 plus 28 is 148. Last one. This one turns into 9 times, breaking 42 up, I have a 40 and I have a 2. So this is 9 times 4 is 360, plus 9 times 2 is 18. 378, adding them up. Distributing a fraction. The first thing you want to do when you distribute a fraction is put a 1 under any whole number. Put a 1 under any whole number. That means if I had a 3, I would write it as 3 over 1. If I had a 5, I would write it as 5 over 1, etc. That's the first thing you want to do. Secondly, you're just going to go top times top over bottom times bottom. Simplify. Always simplify. It's not even in a step. It's just expected, like a reflex. So looking at this first example, 4 times 1/5 x plus 3. I see a fraction involved, so the first thing I'm going to do is put a 1 over any whole number. Anytime I see a fraction, I'm just putting a 1 on the bottom because I'm just going to deal with everything like a fraction. So now I'm going to go top times top over bottom times bottom, and then the x is on the outside. Plus top times top over bottom times bottom. That's all I'm doing. Okay? This turns into 4 over 5x plus 12 over 1, which is just 12. Done. Next one, I see a fraction. I'm just putting a 1 on any whole number. Now I can go top times top over bottom times bottom. 2 times 5 over 5 times 1x minus, the minus is coming down, top times top, 2 times 10 over bottom times bottom. 10x over 5 minus 20 over 5. I can simplify that though. What's 10 over 5?
1/2. 2 over 1, 2.
2. 2 over 1, which is 2. 2x minus, what's 20 over 5?
4.
4. 2x minus 4 is final simplified answer. Bless you. The last fraction example, I'm going to do it fast. Now I'm not going to show this step. I never really show that step. I just showed it while I was teaching you explicitly what we do. Okay? I do it all in my head. I just go top times top, 1 times 9 is 9, over bottom times bottom, 3 times 1 is 3, put the x out there, minus top times top, 1 times 16 is 16, over bottom times bottom, 3 times 1 is 3. I can simplify. 9 over 3 is what? It's not 1/3, it's just 3. 3x minus 16/3, leave it. I can't simplify 16/3, so I'm just going to leave it.